It's like a blast of hydration. Chic Hydro. Water. Come on guys, stop mucking around. We only have 5 minutes until our show's on.
That's not enough time!
There's always time for a song.
What? Who is that?
Time is a tool you can put on the wall or wear it on your wrist. The past is far behind us. The future doesn't exist.
Oh, what's the time?
It's 9:15. Time to have a bath.
What do you mean? We're already clean!
Scrub, scrub, scrub till the water's brown. Time is a ruler to measure the day. It doesn't go backwards, only one way. Watch it go round like a merry-go-round. Going so fast like a merry-go-round.
Let's go on a journey through all time, a time that's changing all the time. It's time to go to time.
But we don't really want to. We're going to miss our show.
Don't be stupid, friends. Come on, it's time to go. Time was old, like a Victorian time. With cobbles and playing and speaking in rhyme.
With cobbles and chimneys, a simpler time.
This tree that is old has circles inside.
A tree that is older has shriveled and died.
The apple that's fresh is ripe to the core.
And I rot over time and I'm not anymore.
Time can be told by the moon or the sun, but time flies fast when you're having fun. There's a time and a place for mucking around.
Like birthdays.
I'm friends with my dad.
And then what happened after the olden days?
Time went new and got old like history. Stuff from the past went into a mystery.
An old man died.
Look, a computer. Everything's cool. It's the future. Time is now. The future are new. Look at all the wonderful things you can do with gadgets and gizmos and email addresses.
My dad is a computer.
Look at the time.
It's 8:45. There's fish on my plate.
It's 8:20. There's fish on my tray.
It's 11 to 12. There's fish in the bath.
It's 9:30. There's fish everywhere. Fish everywhere.
Now you can see the importance of time. It helps us make pizza. It keeps things in line.
But when did it start?
And when will it stop?
Time is important, and I am a clock.
If we run out of time, then where does it go?
Is time even real? Does anyone know?
Maybe time's just a construct of human perception, an illusion created by...
Sunrise, sunset, night and day. The changing seasons, the smell of hay. Look at your hair grow, isn't it strange? How time makes your appearance change.
Make it stop!
It's out of my hands, I'm only a clock. Don't worry, I'm sure you'll be fine. But eventually everyone runs out of time.
Sorry? Yeah, good video. Really demonstrates some of the concepts that we've been exploring. Like, it actually did cover the growing block theory, like the idea of perception of time, time passing, and also how things die. And then there was that bit about that guy's dad who seemed a bit problematic. All right. Hush you. Okay, so don't forget that you've still got a day to get your time machine plans in. This is the first entry.
How much satire is allowed?
Oh, as much satire as you're humanly capable of, I would think. I don't know what your capacity for satire is. I mean, I know the general human capacity for satire. I don't really know that. Yeah, you know, stuff. Okay, So today we're looking at time travel. But first I'm going to take a stroll down memory lane, all of the things that we've experienced so far, all of the fun that we've had, because it's almost over. And you guys will be sad when it's done, because time flies. All right, so first of all we looked at causation, and we drew this distinction between process theories of causation and counterfactual theories of causation. And process theories of causation involve the existence of certain kinds of processes that involve the transfer of some kind of thing, energy, motion, momentum, these sorts of things, and that's what ends up underpinning causation. These accounts of causation have trouble with omissions, right? How do you explain the omission of something doing causal work when it doesn't look like there's any process underpinning it? Then we moved on to counterfactual theories, which seemed like they would be able to handle causation by omission. Why? Because counterfactual theories don't require any underlying processes, or so it would seem. Memories. Okay, then we looked at models of time. We had the moving spotlight theory of time, the branch attrition theory of time, the growing block theory of time. So the growing block theorist thinks that only the past and the present exist, otherwise known as the growing salami view, otherwise known as the sausage view, apparently, according to the Chute. The past is far behind us. And then we had the branch attrition view, the idea that as the present moves on, branches fall off the tree of reality and never existed once they've fallen off. Then we had moving spotlight view, the idea that the present moves through time like a spotlight moving across a wall. And then we had presentism, our lonely friend presentism. The idea that the past and the future don't exist, only the present exists, but the present continually changes, right? Then we looked at some particular problems for presentism. So we looked at truth-making problems, the idea that claims about the past are true, but there's nothing around in the present to make them true. And we injected some things into the present to get truths about the past. So things like tensed properties, memories in God's mind, if you're into that sort of thing, abstract objects. These are all sorts of proxies that you can find for past things that you might be able to use to do truth-making work. And we looked at the problem of relations, the idea that presentism doesn't have any past things, and yet past things seem like they stand in relations to present things. Given that they stand in relations to present things, and given that relations seem to call into existence both of their relata, how can presentism be compatible with any relations? And we saw one way to solve that was to thicken the present. Another way to solve it was to reanalyze all of those things that seem to be relational in non-relational terms. Then we had presentism and special relativity. Unfortunately, Billy's falling off the bottom of the screen. Basic idea here being that certain aspects of our current best science seem incompatible with presentism. In particular, the relativity of simultaneity is at odds with presentism if you're prepared to link presentness to simultaneity, right? We had a look at some ways in which you could pull apart presentness and simultaneity, and we also looked at some ways you might give up the special theory of relativity. The sort of best option, it would seem, or it seems to me, is to sort of take a more detailed look at science, and you'll see that it's actually not settled that presentism and STR, well, it's settled that presentism and STR are compatible, but it's not settled that presentism is therefore incompatible with our best science, because special relativity is superseded by general relativity, and general relativity is going to be superseded by quantum gravity, and some pictures of quantum gravity admit that there is an objective time ordering, which would be enough structure to get an objective present. All right, so that's what we've done. Good times. And now we're going to look at time travel. And time travel involves the combination of causation and time. And what you're doing is traveling around in time to make certain freaky things happen and see what follows from that. Like doing things like trying to kill your grandfather, or trying to murder your infant self, or indeed sending soldiers, thousands and thousands of soldiers into the past to constantly try and kill their relatives or their infant selves, right? So we're going to talk later on about the Institute for Auto-Infanticide, which is an institute formulated in the future with the express purpose of trying to send people back in time to kill their former selves. And I didn't make this up. This is a philosopher. Of course it was a philosopher who came up with this thought experiment, right? But the Institute for Auto-Infanticide was hypothesized by Paul Horich, Thank you, Paul. All right, so what I'm going to do today is just give you a little bit of a brief introduction to time travel mechanics. One of the sort of things that people first say about time travel is, isn't it like ruled out by the laws of nature? I'm going to give you 3 ways that the current physical laws permit time travel. And then I'm going to look briefly at the grandfather paradox, right? The paradox involving traveling back in time and trying to kill your grandfather before your father was born, or indeed traveling back in time to try and kill your infant self. It's the same problem, right? Looks like you bring yourself out, take yourself out of existence when you do so, in which case you never travel back to take yourself out of existence. Yeah, Matt. Yeah, later on we'll get to exactly what conception of time we have and how the conception of time relates to issues to do with time travel. So what you'll see is that time travel is much harder to make sense of on a dynamic theory of time, right? So it's much harder to make sense of if you're a presentist, for instance, right? So imagine you're a presentist. We'll talk about this, I think, next week. Imagine you're a presentist, right? Someone has a box in their office, and they're like, it's a time machine. You step in there, you'll travel back to the past. Is it a time machine, or is it a suicide booth? Okay. Time travel mechanics. So we're all traveling into the future, right? So in some sense, we are all time travelers, okay? It's just that, and we're all traveling into the future at different rates, as it happens, right? Depending on your state of motion. And not just that, but forward time traveling into the future, right? So we're all traveling at roughly the same rate into the future, depending on how fast you're going. But time travel into the sort of distant future is known to be possible, and not just possible, people have actually done it, right? So any astronaut who's been orbiting the Earth for a sufficiently long period of time will have traveled into the future a tiny, tiny little bit, like a fraction of a second, something like that. Because they're not traveling at super relativistic speeds. They don't travel much further than that. But if you were traveling at like half the speed of light or 3/4 the speed of light, you would be able to travel into the future. And this is what the twins paradox is supposed to demonstrate. So you've got 2 twins. Check out this animation, by the way. This is hand-built in PowerPoint. Right in PowerPoint. Anyway, so you've got two twins, and one twin stays on Earth, the other twin gets into a spaceship, and they travel off at, half the speed of light, and then they return, and by the time they return, their twin has aged a significant amount, but they haven't aged at all. And this is one of the it's called a paradox, but it's not actually a paradox, it's just a sort of direct corollary of relativity, that when you travel at high speeds, time slows down for you, and when time slows down for you relative to the place that you left, it means that you age a lot less than the people that are stuck on Earth, right? So the person who travels on their spaceship and then comes back to an older twin has traveled into the future in some sense, right? But what we're interested in is backwards time travel, right? So it's true, look, yes, we all travel into the future. Yes, you can travel into the distant future if you can go fast enough. That's completely accepted by relativity. But the question is, can you travel backwards in time? Can you travel to the local or distant past, right? And it's not obvious that you can make sense of this on sort of standard pictures of time, like Newtonian pictures of time. But actually, relativity does sort of allow. But before we get to that, I want to just give you 2 ways of thinking about backwards time travel. And these 2 ways of thinking about backwards time travel kind of line up with 2 different ways of thinking about causation. So all instances of backward time travel require retrocausation, right? You have to do something now which causes your appearance in the past, right? Like you have to step into a time machine, and your stepping into the time machine causes you to pop up as Caesar's crossing the Rubicon and be like, hey, Caesar, nice job. But it looks like there are roughly 2 ways to make sense of how it is that you could get into the past. One of them is via some process, some causal process that runs backward in time, right? Some sort of continuous chain of events such that at the start of the chain you're in the present, and at the end of the chain you wind up in the past. Okay? And so this is going to line up very roughly with the process theory of causation. Imagine the processes, these things strung out in space-time. Now imagine one of those things which wraps back on itself, right? That's going to be, very roughly, a sort of process-based account of time travel, where you're traveling backwards in time through some continuous process. There's another way to think about time travel which may not involve processes. If you think about causation in terms of counterfactuals, and you think that something like the following counterfactual is true, if I had not entered the time machine, I would not have been transported back to 1952. Or if I had entered the time machine, I would have been transported back to 1952. Right? These are counterfactuals which involve the antecedent being present and the consequent of the counterfactual being in the past. Right? And because counterfactual causation doesn't require any processes, time travel built on the back of backtracking counterfactuals of this kind may not require any processes either, right? And I kind of think of this as like opening up a kind of temporal teleportation, right? So when I travel to the eastern states, I go and get in a plane and fly across to the Sydney and land and be like, whoa, Sydney, great, it's fun. And there's some continuous path that takes me from Perth to Sydney, right? But there's another way I could travel to Sydney, which is to step into a teleporter and just appear in Sydney the next moment, right? Without there being any intervening continuous path. And the counterfactual would just be, you know, if I hadn't stepped into the teleporter, I wouldn't have appeared in Sydney. If you think about continuous pathing, right, think about sort of running some continuous line back in time to get to the past, then you're going to be thinking in terms of processes. If you think about this teleportation idea, the idea that I might just step into a teleporter now and then appear in the past without there being any continuous path between me and the past appearance of myself, then you might understand that using counterfactuals. This is very similar to the notion of action at a distance. So in certain areas of quantum mechanics, we have this idea, which you've probably heard about, at least in a pop science way, if not in an actual science way, the idea that when you measure a particle in an entangled pair, you immediately get information about the other member of that pair, right? And some people have used this as a basis for teleporting bits of quantum information, right? And what people say about this is it's action at a distance in the sense that, you know, something you're doing here seems to have some kind of effect. This all has to be in scare quotes, so I don't think causal language is particularly useful for thinking about spatial action at a distance. You're making some change here, and then there's some effect across in space, and it's not happening by a continuous path of events. It's sort of happening instantaneously. Similarly, you can think about it, same sort of thing in time, right? You make some change in the present, step into a time machine, and then you just instantly teleported to the past. You're not moving there via some continuous path. Okay. Insofar as our current best science allows for time travel, it's time travel of the first kind. Science doesn't really have much to say about the teleportation kind of time travel. And I'm not really sure what to think about the teleportation kind of time travel. I'm inclined to think that people in general, when they think of time travel, actually have the teleportation picture in mind rather than the sort of continuous pathing picture. But it's not actually clear that it makes sense and that it's coherent. Interesting idea to try and see how coherent that sort of picture is. Anyway, there are three pictures in physics that at least say that time travel is possible. They're also pretty far-fetched, right? So while they say that time travel is possible, at least physically possible, they also say, but it's probably not going to happen anytime soon. Okay, first option. If you happen to have two black holes handy, okay, what you can do, apparently, so I've heard, is if you've got a spaceship that travels faster than light, I mean, this is all like if you've got to travel, yeah, of course, I've got one of those hanging around. You've got a spaceship that travels faster than light, you can go into a black hole but not fall like all the way into it, just sort of stay at a certain distance just beyond the event horizon of the black hole. And if you go round and round and round and round and round the black hole really fast, supposedly the time will start to go backwards and you'll pop out of another black hole in the past. This is supposed to be the case. The trouble is that you need to set up the two black holes in the first place, right? So you need to be able to have a black hole in the present that you've harnessed, a black hole in the future that you've harnessed, and then have a faster than light spaceship that you can go and, you know, shoot and like fly around a black hole. So, I mean, although it's sort of theoretically possible, you can see that it's not going to happen anytime soon. Yeah. Is a faster than light spaceship theoretically possible? Depends on what you mean by faster than light. That's all I'm going to say about that.
The one thing we'd agreed on was that was a constant speed. Well, that was
Yeah.
the only thing.
Okay. Yeah. But something might travel faster than light without accelerating faster than light. If you fold space, right? So if you can have something that takes it. So imagine there are 5 spatial dimensions, right? And you have a ship that can take a detour through the 5th spatial dimension to get somewhere in the 4th spatial dimension that would take you a long time if you're traveling in the 4th spatial dimension and a faster than light ship. You might be able to travel faster than light by taking a detour around space. Or, I mean, if you've seen Event Horizon, that movie with Sam Neill in it, where he like scratches out his eyes and loses his shit. Yeah. In that movie, they talk about a gravity drive, and he does this. He's explaining it to some soldiers. He's like, imagine you get a piece of paper and you fold it in half and then punch a hole through the paper. You can get from here to here without traveling. Yeah. Anyway, faster than light. Enough said. All right, the second way to do it is via a wormhole. We've all heard of wormholes. Wormholes are shortcuts through space-time. They allow you to travel very long distances without having to travel the intermediary distance at a sort of slow, normal speed. Right? And these Einstein-Rosen bridges or wormholes are theoretically possible given general relativity, but again, sort of, you'd have to find one in order to harness it as a time machine, and even if you could find one, there's no guarantee that it would send you anywhere interesting. Yeah.
Is this a paper example? The Einstein-Rosen bridge?
Is it a paper example?
Is it the one where you fold that over and rather than traveling all the way?
Yeah, that's right. That's this one where you fold, like if you fold the paper in half and you punch a hole through, then wormhole might be a way of connecting 2 regions of space-time that are connected in a different way, but you're traveling through like a much shorter path between those two points. Yeah. Yeah, because we're not folding a 3-dimensional object, we're folding a 4-dimensional object. Yeah. And one of those dimensions is time. But you mean you can't imagine folding time? Get out of my class! I mean, if you can't imagine that, then clearly you failed. All right. So those are the first 2 ways. The third way is, so Kurt Gödel, who was a troublemaker in mathematics, who did nasty things like prove the incompleteness theorems, which sort of broke mathematics for us for a while. Thanks, Gödel. Had his PhD, I think, by the time he was 16. Yeah, in mathematics. I mean, holy shit, right? Later in his life, in about the 40s, he found a solution to Einstein's field equations. So the field equations are these equations that tell you roughly what the geometry of the universe is going to look like, given the mass-energy distribution across the entire universe, right? So you know how mass and energy sort of deform space-time to create like this, you know, you've all heard the rubber sheet. Imagine there's a rubber sheet with balls underneath, and the rubber sheet is sort of like deformed by the object sitting in the sheet or under the sheet. The field equations tell you how that deformation is going to look. And he found a solution to the field equations which allowed for this thing that's this weird rotating universe where you have paths through space-time where you're constantly traveling in a forward direction into your future, but you end up looping back on yourself because of the topology of space-time. You can sort of get a rough sense of this. Imagine you're standing on a sphere, right, and you set off in a particular direction. By going constantly forward, you'll end up coming up from behind yourself, right? Similarly, if you've got, I mean, now I want you to imagine a 4-dimensional sphere. You've got that in your heads, right? Right? 4 dimensions. I mean, it's easy. Just imagine n dimensions and that n equal 4, right? Okay, so you've got a 4-dimensional sphere in your head. You can travel in a certain direction along that sphere and then come up from behind you. It's just that it's a sphere of time is what I want to say. It's not a continually looping universe because this is like a 4-dimensional. Like, remember in eternalism, everything past, present, and future was laid out, right? It's like that. It's one of those universes, except that there are closed causal loops in the universe, right? Situations in which you start something here and you go along, and it ends up being the case that you were the cause of you setting off in that direction in the first place. Eternalism could make sense of that, but it's not going to fall out of the geometry of the space-time. On Gödel's view, it falls out that there are such things, or at least that such things are possible given the structure of space-time. It's very cool, but one of the things is that there's no way that this is what our universe looks like. So although he's given you a possible solution to the field equations, right? This is what the topology and the geometry of the universe could look like. We know from our universe that it's not like that because our mass-energy distribution isn't such that you could solve it in this way, right? That's right. I'm pretty sure that's exactly what led Gödel to do this, right? He was like, look, I broke mathematics. What else is there to do? Yeah, Doctor Who's pretty awesome. Let's try and make that stand up. Yeah, so maybe this is how the TARDIS works. Okay, so that's just some basic, just to give you some sense of how it is that you might be able to actually travel backwards in time. The laws of physics allow it, but one of the other things I should say about this is Gödel also showed that the amount of energy you would need to actually travel along one of these trajectories is greater than the known energy of the universe. So, you know, that's a bit of a limitation. Anyway, but nonetheless, it's an interesting conceptual question as to whether time travel is logically impossible, right? So physics seems to say it's physically possible, but there are reasons to think that some people have thought that it's logically impossible. So what I've given you here is an impossible figure, right? Can you all see that? It's so cool that you can draw impossible objects, right? Your homework is to build that. I want an actual model of that. Okay?
Is it acceptable to fold time to do so?
If you can do it by folding time, I won't deduct marks. Okay. All right. So the grandfather paradox. Tim the time traveler travels backwards in time with murderous intentions to kill his grandfather before his father was born. If Tim succeeds, he will never be born and will never travel back. So he will bring it about that he both does and does not travel back in time. Paradox. Right? Straightforward logical contradiction from traveling backwards in time and trying to kill your grandfather. Okay? Suppose that Tim tries anyway. Right? He travels backwards in time. He takes an arsenal of weaponry, or otherwise gets hold of an arsenal of weaponry. He finds his grandfather. He lines him up. He takes a shot. And what happens? Well, David Lewis, the influential American philosopher, for some reason that says that on that slide. I mean, he was, but I don't know why I'm telling you that, because you already know that. He tells us that the universe is subject to global consistency constraints, right? Such that logical paradoxes, logical contradictions can't happen. And because logical contradictions can't happen, right, they're impossible. It's impossible for P and not P, right, the law of non-contradiction. Then Tim is going to fail to kill his grandfather, right? But why does he fail to kill his grandfather? Well, Lewis says, for some commonplace reason. When he tries, his gun is going to jam at the last minute. Or he's going to have a sudden change of heart and decide that actually his grandfather should be spared, he shouldn't be trying to kill his own grandfather, so he gives up. Or a pigeon flies in the way whenever he takes a shot. Lots of pigeons, they just keep flying. He's got a machine gun, it's just like a flock of pigeons, right? Or he slips on a banana peel, that's the other thing that Lewis says. Not without a sense of the slapstick was dear Lewis. And that's why he fails to kill his grandfather, right? So on the one hand, you've got these global consistency constraints about logical paradoxes being impossible. And on the other hand, you've got something that will happen to stop him from killing his grandfather. And Lewis says it doesn't matter what it is. Some accident is going to have occurred. Why is it the case that some accident is going to have occurred? Because some accident must have occurred, right? He did, as a matter of fact, fail to kill his grandfather because he's alive in the present, right? If he had actually managed to do it, then he wouldn't be alive in the present to try, right? So he must have already failed. Given that he must have already failed, there must be something that stopped him. Doesn't matter what it is, okay? Matthew. All right, so here's an example, which you're all hopefully familiar with. If not, I suggest you go home and watch Futurama. Yes, Oliver.
Doesn't that show that it would be possible so long as you don't do anything that would contradict?
So here's the thing. Suppose that we use the grandfather paradox because it's very illustrative. It's like obvious to see how the paradox is going to arise. But actually, any paradox, any change to the past will do. Right? So suppose that the past is a complete set of truths about how things were. Right? The thing that the present has had so much trouble giving us. Let's suppose you've got that complete set of the truths that are true now. Right? You travel back in time, and you make it the case that one of those truths is not true. Right? You change the truth value of one of those claims about the past. Right? Looks like the past both includes the claim that P and includes the claim that not P, which is going to be a contradiction. So traveling back in time with the expressed purpose of changing the past in a way that the past wasn't already changed, right? So going back in time to make it the case that Hitler never rose to power, even though we know that he did, right? That would be a contradiction of exactly the same kind as traveling back in time to try and kill your grandfather, right? The key is changing the past, not trying to do something that is explicitly going to undermine your own existence. It's just that's a particularly salient example of it, right?
I just meant that does going back in the past itself entail a contradiction of...
No, it doesn't, right? Because the set of truths about the past could have always already involved you traveling back, right?
So I don't see... I guess the grandfather paradox just highlights ways in which time travel can happen logically. It doesn't say that time travel logically itself. If you don't do anything like this.
Well, the argument would be something like this. If time travel is possible, then it's possible to kill your own grandfather. If it's possible to kill your own grandfather, it's possible to bring about a contradiction. It's not possible to bring about a contradiction. Therefore, running backwards with modus tollens, it's not possible to travel in time.
It just seems like though that Lewis's argument would only work on that jump between where you say you do something in the past to logically change causation, so killing your grandfather.
Yeah.
But it doesn't rule out the possibility of being there shooting at your grandfather, that is having time travel.
No, of course. Lewis says that it's completely reasonable and coherent for you to travel back in time and to try. It's just that you won't be able to, right? On pain of contradiction. Yeah. Questions? Did you have a question, Brody?
I did, but...
No. Okay.
If, say I'm in the future and I get in a time machine and I go back some random person.
Yeah. Yeah.
But through another causal history, the following dice so history changes, but there still ends up being a time machine invented in the future.
Yeah. Yeah. That's still a contradiction, right? Because the past was one way, right? It's both true that Napoleon, what was he, did X, lost the Battle of Waterloo, let's say that. And then you go back in time and you make him win. So then it's true that Napoleon won the Battle of Waterloo, right? And so is it both true and false that Napoleon won the Battle of Waterloo? Well, we don't want to say that. Is it true that he won the Battle of Waterloo? Well, no, because you went back to make it false that he won the battle. Is it false that he won the Battle of Waterloo? Well, no, because it was true that he won the Battle of Waterloo. So you can see that you can go back and help him lose, right, if you want to.
You might need to be there.
Yeah. I mean, the beautiful thing about this is it gives you carte blanche to do whatever you want when you travel back in time. Because whatever you do was already done, right? You can't, break the universe by doing it. I mean, there's sort of moral reasons not to travel back in time and do horrible things. That's right. That's right. Even doing that. So what would have to be the case is that pigeon was always killed by you in the past, right? So it was always a case that you were going to travel back in time to kill that pigeon, right? Okay, let me just press on because there's a couple of things I want to do. Okay, so here's an example from Futurama, and this is an example of a closed causal loop, right? So Fry travels back in time and he meets his grandfather, and he's really worried because he doesn't want his grandfather to die, because he's like, if my grandfather dies, I'm going to stop existing, right? This sort of typical time traveler worry. He travels back in time, and he spends all this time trying to save his grandfather, right? Trying to get him out of danger. His grandfather lives on a military base. And in the end, he's like, this military base is just too dangerous. So I'm going to take him out in the middle of desert into a little shack, and he can stay there, he'll be safe. And then he takes him out, and as he's driving away, a nuclear bomb explodes on the shack, and he drove his grandfather out into a nuclear test site. And he goes back into the town, he meets his grandmother, and he consoles her, and in consoling her becomes his own grandfather. Okay, so that's like a nice pun on the grandfather paradox, right? He is his own grandfather, which actually helps him later on to like defeat the universe from these big floating brains, because he's got this like special brainwave because he's his own grandfather, and that's like nasty, right? Anyway, it's genetically bad, I'm assuming. Okay, so you might have the following response, but surely Tim can kill his grandfather, right? He travels back in time, he's at, you know, the grassy knoll, maybe his grandfather's JFK, right? He's there with the gun, right? He's trained for years and years and years to be a perfect marksman, right? So there's no way that he would miss if he fired. His gun is working in perfect order, right? He's just psychologically such that he's never going to have a change of heart. Surely he can kill his grandfather, right? Now imagine he was in the present, right? Exactly the same situation. He's sitting on the grassy knoll, aiming his gun at his grandfather. Surely he can do it in the present, right? But the physical facts in the present, aren't they just the same kinds of physical facts that there are in the past? Why is it that he can't do it in the past, but he can do it in the present, right? So this is a sort of response to Lewis. So he has what it takes, and yet he fails. He must fail. That seems a bit dodgy, doesn't it? Okay. So what Lewis says here is that there are two senses of can, and these two senses of can are supposed to explain the intuition we have that Tim can kill his grandfather, but also explain why it is that he can't kill his grandfather, right? What he says is that there are two notions of can depending on the set of facts that you're paying attention to. If you're looking at the local facts about space-time, around which, so Tim's in the past, you just look at the facts involving sort of the last few seconds and the next few seconds into the future and sort of the physical facts of the universe, then yes, compatible with those facts, he can kill his grandfather, right? Sort of locally compatible with those facts. But if you take into account the full facts about the universe, right, including the fact that he didn't kill his grandfather in the future, right, and that his grandfather survived, then once you look at those set of facts, or that set of facts, then it's clear he can't kill his grandfather. So Lewis says that when we have the intuition that Tim can kill his grandfather, even though we sort of have this background consistency constraint, what he thinks explains the intuition is that we tend to just focus on these local set of physical facts when we're making judgments about possibility and agency and what you can and can't do, right? But if you actually take into account the full broad set of facts about space-time when you're determining what people can and can't do, then it turns out that he can't kill his grandfather, right? So what he does is he manages to save the intuition that Tim can kill his grandfather, whilst nevertheless saving the fact that he can't kill his grandfather because of the paradox, right? And then he charges us with equivocation insofar as we disagree. All right, so that's all I have to say about the basic time travel picture. As I said, next time I'm going to be talking about the Institute for Autoinfanticide. So the Institute for Autoinfanticide is a response to the Lewis argument that I just presented. And the Institute for Autoinfanticide, as I said, involves training armies of soldiers and sending them back in the past. Just to give you a flavor of what the warrior is going to be, Lewis says that some coincidence, right, something gun jamming, sudden change of heart, steps in to stop you from killing your grandfather. Imagine thousands and thousands of people travel back in time to do it. They're going to be subject to gun jamming, sudden change, they're going to be slipping on banana peels all over the place, right? The past is going to become this comedy of errors where there are all these coincidences, right? And Paul Horrich says, ain't that a bit dodgy? All right, we'll come back to that tomorrow, next week. Sorry, Adam? Yeah, it already was a comedy of errors. So you get a much weaker conclusion out. I'll talk about that next time. Did you have a question? Any other questions? No? Going once? Going twice? Sold to the man in the hat.
Surely it's impossible to picture it because pictures are visual and vision works in vision. Unless you can say you can see time, in which case, good luck to you.
not as if it's not as if it's a difficult idea. It's just a difficult thing to rationalize. Like I walked in thinking I knew what the grandfather paradox was all about.
Visualizing things in
Now I've kind of lost everything.
There's a difference between imagining something and visualizing. For example, you could imagine that there is a color. No,
I think I will email you.
I doubt you can visualize
Yeah.
it. Like, it sounded like you can imagine something. You can imagine
Well,
yeah.
I've got to ask you
Yeah,
about
so you can imagine that something is invisible. You know what it is to be there, and it's generally defined
When
by
you take on someone that might take a
so
PhD, what sort of
this is it because it's not.
No,
like
they'll be happy to take on
so infinite is
anyone.
something that is not zero.
They want to
and
take on the
also
best students they can.
Not anything that
It would be easy to supervise.
Yep.
They want to take on someone who's in doing stuff that they're interested in.
maybe whatever. Well, my point
They want to
is
take
this.
on someone
It could,
who'll be,
whatever you want to verbally.
well, depending on the supervisor, but
You can
typically
sort of
active in
understand.
the department.
You might understand
Join
conceptually what is
boards and
required without being
stuff
able
like
to
that.
visualize it.
Fine. Beyond that, I don't think there's constraints to that having to go on with philosophy.
But I think it is.
Although going to Sydney should do honours if you're not going to go on with philosophy. You might think that there's not that great a benefit to doing that versus doing it here, depending on what your goals are in the future.
Well, it's just not
People that do stuff they want to do here.
yeah, but stuff like honestly,
I have determined that it is a very
yeah.
Yeah, fair enough.
And those that don't have wheels, the fighting types of men are sort of chest.
Yeah.
It's very vague.
Come on, guys, let's vacate the.
Hey, where are the huts?
You guys bitch and moan so much about time for a course that's on time.
Yeah. I have like tiny notes, but not I don't have like extra notes. How long do you write? Exhausted. Not like study, right? What do you have to do? Oh, you have to do with me. So this no, I have this today. And I have this summary that's finished. Haven't done journals? Haven't done my journal yet, but
I did my journals today.
You finished it.
I've been doing it every week. No, I don't.
Wait, is it A4 or A5? Oh. No, I haven't started yet. I mean, I have all the articles.
You were going to do it on the weekend.
No, I was working on the weekend. I was doing that on the weekend.
Yeah, that's F4. Yeah, no, because I've actually been doing it every week. Because I did it at Thursday night when I was at work. So then I actually do it. It's not really a problem. No, I did the last one today. Then
I only have tonight for one to do it because work. And then it's a set for rat or rat.
No, I'm not going to study for that. I'm worried about IMC.
Yeah.
I'm studying for that.
Yeah, I'm going to study for IMC.
I haven't studied for a single rat test yet.
I'm
So
going to study
I
for
Finished the reading?
what? For this? No.
For
no.
this?
Yeah.
Oh,
IMC.
God. I was like, what do you mean? Six chapters.
I was just like,
Yes,
no.
yes, there's no reading this week.
It's
What are you
not
talking
work.
about? Do you want to use your laptop? Yes, because I've been doing them every
You
week.
haven't sent me the PowerPoint yet.
Oh, okay, I'll send it to you now.
Why do I have to use my laptop? You have to upload it there.
Oh, okay, well, I'll put it on my USB.
Yeah.
Easy. I didn't end up writing down notes, so I'll just forget. That's what he was just saying.
Yeah. Comms